Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. This is an example of simultaneous linear equations. If you look at the three equations, you can see that there's no squares in them. They're all single powers of letters x, y, and z in this case. Okay, so there's a couple of steps when you're asked to solve one of these in your Leaving Cert. This one is from the 2010 paper 1 Leaving Cert paper. It was pre-project maths, but the maths is the same. Okay, so a couple of steps to it. You look at each of the equations and you make sure that they're aligned perfectly. So the x's are over the x's in this case, the y's are aligned with the y's, the z's are aligned, and they're all equal to a number. So they're all nicely aligned for us. The first thing you do is you label your equations 1, 2, 3, and that's so you can refer to them easily enough. Okay, and then you select a pair of equations and you eliminate one of the letters from it. You then select the equation you haven't used and one of the other ones, and you eliminate the same letter. That's really important. It has to be the same letter that you eliminated. Then you solve them, you bring those two new equations together and solve them, and then you go back and you get the other letters. Okay, and those steps will make more sense as I go down through this one. This one is a little bit unusual, and that's why I wanted to do it, in that if you look at the top one, you have no z, okay? So it makes sense then to take the bottom two and cancel out the z in them, because remember step 2 and 3 were basically cancelling the same letter in pairs of equations. So let's take 2 and 3 together. So it's x plus y plus z equals 0, 3x plus 2y minus 4z being equal to 9. Okay, so like I said, it makes sense to cancel the z's so that it matches up with the top one here. When I say cancel, I mean cancel to 0. So to cancel anything to 0, if you think about it, you have plus 1 minus 1 is 0, plus 10 minus 10 is 0. In the same way, plus y minus y would be 0, plus 20y minus 20y would all be 0. So in any of these cases, you can see as long as I have a plus and a minus of the same variable or number, okay, they cancel to 0. So that's the theory behind what we do when we need to cancel a letter. So in this case, I'm looking at my options. I have minus 4 here, minus 4z and plus 1z. So I can see that if I multiply that top one by 4, I will bring him up to plus 4z. He's already at minus 4z, and then they'd cancel. Okay, so let's do that here. So it's 4 by z to give me, or 4 by x to give me 4x. It's the same way, 4 by y gives me 4y. 4 by z gives me 4z, and 4 zeros are zeros. So very important thing to note there, I didn't just multiply z by the 4, you have to do it to the whole equation, and that's to maintain the balance of that equation, okay? You can't just select one little piece and do it. And then the next line stays the same because we're happy with minus 4z. Okay? Plus 4z minus 4z cancel. It's like an old-fashioned sum that you would have done in national school. We just put a line under them and we add them. Okay, so 4x plus 3x is 7x. 4y plus 2y is plus 6y equals 0. And that gets called equation 4. Okay. And then in a normal one, I would have chosen equation 1 because I hadn't used it, and either 2 or 3, and I would have done the same process, cancel the z's, to create equation 5, and then I would bring a 4 and 5 together. Okay, but I don't need to create this equation 5 in this one because equation 1 is already minus any z's. So instead I bring that equation 1 and this new equation 4 together, so that I get 2x plus 3y being equal to 0 7x plus 6y being equal to, I made a little mistake here, mad for my zeros, apologies, that should be a 9. This should be a 9 here, okay, equal 9. Okay, so when I look at these two now, I have to decide then, does it make sense to cancel the x's or the y's? And it doesn't matter which one you do, you look across at them and you decide which one looks easier for you to do. I'm looking at them and I think if I multiply that top one by 2, it would bring the y's up to 6. So I'm happy with that. Let's go and do that. So I have 2 2's or 4x plus 6y equals 0. And then the bottom one, take it down, equals 9. Okay. It doesn't cancel at the moment because if you look at the y's, I have plus 6 plus 6. They don't cancel to 0. If I add them, they get 12. So they're not cancelling. So what I need to do is I need to change the sign all the way across on one of them. So it doesn't matter which one you change. I'm going to change the top. Okay, and then I'm going to go 7x minus 4x. So you can read them backwards if you wish. Is 3x being equal to 9 minus 0 is 9. Then divide both sides by 3. And I'm getting x being equal to 3. Okay. So that is one of my solutions. Okay, how do I find my next one? Well, in a normal one, you would go back to either equation 4 or 5 and sub in your x is equal to 3. Why don't I go back to 1, 2, 3? Well, it's because if I went back to, 2, 3 in this case, I would know my x, but I would still have 2 unknowns and I wouldn't be able to solve it. Okay, so in this one, I can go back to either of these two, because remember I know equation 5, so I can go back to either 1 or 4 and solve for the other letter. I know my x, so I'm going to be solving for y. Okay, so let's do that. Let's sub into, and it doesn't matter if it's 1 or 4, but we'll sub into 1. And again, it's whichever one you like the look of. So instead of x, I put in 3. 6 plus 3y is equal to 0. 3y is equal to, so minus 6 from both sides, or bring over your 6, whichever way you prefer to do it, and divide by the number in front of the letter. So I'm getting y being equal to minus 2. Okay, and then now I know x, now I know y, now I go back to one of these two and solve it for z. I'm going to sub it into equation 2 because it looks easier. So sub x is equal to 3 and y is equal to minus 2 into equation 2. Equation 2 is x plus y plus z is equal to 0. So I have 3 minus 2 plus z is equal to 0. 3 minus 2 is 1 plus z is equal to 0. Bring it over, z is minus 1. Okay. So that's how you solve the simultaneous equations. Before I go though, I want to show you how to verify. Okay, so rather than going on to a new page, I'm just going to blot out the top bit here. So you can watch the recording as often as you need to do the verify, okay? So I'm going to do it up here. Sometimes this gets asked as the next question, sometimes it doesn't. It's good practice while you get used to simultaneous equations, and know that you can do it on your calculator. You don't have to write it down, okay? But it's good practice on your calculator. I would always put in my x values and my y values as such into the calculator and see, does it verify it? So 2 3s are 6 minus 6 is indeed equal to 0. That correct afterwards, after it here, is maths language for verified. Okay, so it's not you correcting your own work, it's not you showing off, it is you telling your corrector, your examiner, that you know you've just verified it. Okay, simultaneous equations are special in that the solutions work in every one of the equations. So just because it worked in equation 1 doesn't necessarily mean I have it solved correctly. Okay, it has to work in all 3 equations. So my x is 3, my y is minus 2, my z is minus 1, so 3 take away 2 take away 1 is indeed equal to 0. That's looking good, it worked for 2 of them. Now let's check it in the bottom one and see is that equal to 9. So I have 3 times 3 minus 2 times minus 2 minus 4 times minus 1, is that equal to 9? So 3 3s are 9 plus 4 plus 4 is not equal to 9. It's because I took it down wrong. You can see how easy it is to make one of the mistakes in these ones. I've made 2 tiny mistakes there. So keep checking your work just like I'm doing. They cancel and you do get 9 is equal to 9. Okay, so that's it verified. Like I said, you can do the purple bit I've written there in purple in a calculator, or you can write it out. Sometimes they ask for it in the bottom of your question. So that's that one solved. If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice. In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.